Hello, good day viewers. In this tutorial, we are going to multiply these two complex numbers together applying the Moivre theorem. And you should know that even if our complex numbers do not contain these powers, you can still apply the Moivre theorem to multiply them. So let me derive the equation we are going to apply in this tutorial. First of all, we have to transform our complex numbers to polar form. And you know that the polar form of a complex number is written as z equal to r multiplied by cosine of theta plus I sine of theta. This is the polar form. But since our complex number has a power, z to the power of n, for instance, this is equal to r to the power of n, then multiplied by cosine of n multiplied by theta, then plus I sine of n multiplied by theta. So this is exactly what the Moivre theorem stated. But since we have two complex numbers z1 and z2, z1 to the power of n, for instance, this is the same thing as r1 to the power of n, then multiplied by cosine of theta 1 multiplied by n, or n multiplied by theta 1 is the same thing, then plus I sine of theta 1 multiplied by n. Then for z2, suppose we have another one, z2 raised to the power of m this time around. This is equal to r2 to the power of m, then multiplied by cosine of theta 2, then multiplied by m, then plus I sine of theta 2 multiplied by m. So this is for the second complex number. So what if we wish to multiply these two complex numbers together? Suppose we want to multiply z1 to the power of n, then multiply by z2 to the power of m. This is the same thing as r1 to the power of n, then multiplied by r2 to the power of m, then multiplied by cosine of what? Theta 1 multiplied by n, then plus theta 2 multiplied by m, then plus I sine of theta 1 multiplied by n plus theta 2 multiplied by m. So finally, this is the equation we are going to apply in multiplying these two complex numbers together. And hence, we are going to transform each complex number here into its polar form. Then we raise it to its power. Let's start with the first one. So this is our first complex number. Let us find r1, which is the modulus. This is equal to the square root of the real part squared, which is 2 squared, plus the imaginary part also squared. This is 4, and this is 12. If you add them together, you have 16. Square root of 16 is 4. Therefore, r1 is equal to 4. Then what about theta 1? Theta 1, this is equal to tan inverse of the imaginary part, which is 2 root 3, then divide by the real part, which is 2. 2 root 3 divided by 2 is just root 3. And what is tan inverse of root 3? Is pi divided by 3. And therefore, theta 1 is equal to pi divided by 3. So what is the polar form of this complex number? z1. Remember, it is r1, and our r1 is 4. Then multiply by cosine of that angle, which we have as pi divided by 3. Then plus I sine of the same angle, pi divided by 3. But remember, our complex number is to which power? To the power of 3. Therefore, z1 to the power of 3 will be equal to 4 to the power of 3. Then multiply by cosine of what? 3 multiplied by pi divided by 3. Then plus I sine of what? 3 multiplied by pi divided by 3. z1 to the power of 3 is equal to 4 to the power of 3, which is 64. Then multiply by cosine of pi, because 3 will cancel 3, plus I sine of pi. So we're done with the first complex number. Let us take the second one. The second complex number is -1 plus root 3i to the power of 2. So here is our second complex number. Let us find R2, which is the modulus. Square root of -1 squared plus root 3 also squared. This is 1, this is 3. 1 plus 3 is 4. Square root of 4 is 2. Therefore, our modulus for this complex number is equal to 2. And what about our theta? It is equal to, if you observe, this is in the second quadrant, which is less than 180. So we are going to assume we are in the first quadrant, using that as reference. But whatever we obtain, we have to take it away from 180, which is pi. So this is pi minus tan inverse of what? The imaginary part, which is root 3, divided by the real part, which is 1. Root 3 divided by 1 is still root 3, and tan inverse of root 3 is pi divided by 3. So our theta, which is theta 2, is equal to pi minus pi divided by 3, which is 2 pi divided by 3, right? Therefore, our theta 2 is equal to 2 pi divided by 3. Therefore, that complex number, Z2, will be equal to R2, which we have as 2, multiplied by cosine of the angle, which is 2 pi divided by 3, plus I sine of the same angle, 2 pi divided by 3. But remember that our complex number is to the second power. So Z2 to the power of 2 is equal to 2 to the power of 2. Then multiply by cosine of what? 2 multiplied by 2 pi divided by 3. Then plus I sine of what? 2 multiplied by 2 pi divided by 3. If you simplify this, Z2 to the power of 2 will be equal to 2 to the power of 2 is 4, multiplied by cosine of what? 4 pi divided by 3, then plus I sine of what? 4 pi divided by 3. So we are almost done. What do we need to do next? We need to multiply Z1 to the power of 3 by Z2 to the power of 2. So Z1 to the power of 3 multiplied by Z2 to the power of 2. This is equal to R1 to the power of n multiplied by R2 to the power of m, right? And these are just the result. We have 64 for this one, which is our R to the power of 3. And we have 4 here as our R2 to the power of m. So we have 64 multiplied by 4. Then inside we have cosine of what? We are going to add their arguments together. We have pi here, right? You can see we have pi here. But what do we have here? We have 4 pi divided by 3. So we are going to add them together. Pi plus 4 pi divided by 3. Then plus I sine of the same thing. Pi plus 4 pi divided by 3. We close. We have 64 multiplied by 4, which is 256. So this is 256 multiplied by cosine of what? Pi plus 4 pi divided by 3, which is 7 pi divided by 3, plus I sine of the same angle, 7 pi divided by 3. All we need to find is cosine of this and sine of this. Cosine of 7 pi divided by 3 is 1 over 2. So we have 256 multiplied by 1 over 2. Then plus I. Sine of this angle 7 pi divided by 3 is root 3 divided by 2. So let's distribute. 256 multiplied by half is 128. So we have 128 plus this multiplied by this would give us 128 root 3 I. 128 root 3 I. And hence, this is just the result after multiplying these two complex numbers together. And I think I should use my calculator to prove this. So here is my calculator. Our first complex number is 2 plus 2 root 3I, all to which power? To the power of 3. And we want to multiply that with a complex number, which is the second one, negative 1 plus root 3I, to which power? To the power of 2. And you can see the final result is what? 128 plus 128 root 3I, exactly as what we have, right? You can see it right here. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.